Okay, let us see another example. We're still on a uniform rod. Okay, a uniform rod, AB, it means whenever I hear a uniform rod, it means that the weight is acting in the middle of that rod. Okay, mass 10 kilograms and 4 meters long, resting in a premium at an angle of 60 degrees to the vertical wall. I mean to the horizontal with its upper end resting on a rough vertical wall. You hear the word rough, it means that you expect friction. And lower end resting on a rough horizontal surface, you also expect friction on the horizontal surface. If the coefficients of friction between the vertical wall and horizontal wall, and the horizontal surface are, and the ladder are a third and a half respectively, find the reaction at A and B. Frictional force at the vertical wall and the horizontal wall. So what do we do first? We start by sketching. So we have this is going to be our vertical wall, and then we also have our horizontal surface, as you see there. Of course, it's going to be perpendicular. Then we have a ladder AB, or a rod AB. Okay. So this is our rod AB. Okay, this is my rod AB, like that. Okay. Then from there, of course, that's the base. So this is going to be my A. This is going to be my B. Okay. You ask yourself, is there contact? Yes. There is contact here, there is contact here. So, if there is contact here, we expect what? A reaction at that. And then also expect a reaction. The moment start there is a contact, we expect reaction. That's the first thing. Do you have the length of the rod or the rudder? Yes. It is 4 meters. Inclined at an angle of 30 degrees. We are done with that. Okay. Do you have the coefficients of friction? Yes. So because this is rough and this is rough, we are going to expect friction. When this one is trying to slide, it's going to slide like this. This one will go their side, so we expect friction this side. So this side, remember, our friction is always given by mu r. And now, here they are giving us where this is the reaction to that surface. Now, here they are giving us our mu, and then that's between the vertical and the horizontal. So the horizontal is a half. So it's going to be a half now, then RB, because the reaction here is B. Then here, we are going to expect friction, but this time upwards, because when this one is trying to slide, the motion is in this direction. So friction is going to be opposite. So it's going to be now a third RA, because the reaction here is A. So this is our frictional force at A, equal to that, and then this is our frictional force at B. At this surface there with that point. So that's what we expect. Really easy. Okay. So from there, what next? They are giving us the weight. So the weight means the weight, because this is uniform, the weight is going to act in the middle. So this is going to be now 10B. That's going to be the weight. Okay. It means that now, if this is the middle, it means that this is going to be 2 meters, and this is going to be 2 meters. Really easy. You start with the basics. Now here, you get your one mark for just putting the sketch right like that. Okay. Find the reaction at A and B. Now there, we take the horizontal, we resolve vertically and also horizontally. Resolving vertically, you see which forces we have acting vertically. We have our third, RA, then plus. We also have RB. Because it's in a premium, means that this and this are equal to this one, which is acting downwards, then B. And I call this equation, one. Then this has resolved horizontally. Resolving horizontally, we have first of all RA is going to be equal to 2. This one is going the other side, which is a half RB. This is going to be equation 2, because the system is in equilibrium. But now, you see R here is equal to that, so we are going to substitute it in there. When I substitute where there is RA, I put it there, so put 2 in 1. So we have now R30 into RA is a half RB equaling to RB. Sorry, this is plus, not equaling to. This is plus RB equaling to 10 gig. So you see this one, I'm going to multiply it by 6. Okay, this is RB over 6 plus RB equaling 7 gig. So when I cross multiply there, we have in 7. When you cross multiply here, you have 1. This will be 6 plus 1, 7 over 6. So you have 7 RB equaling 2. Now it's 6. We'll multiply that side. Okay. 6 equaling to 10, and it's 9.8. Then you see from there, we can aggregate our RB. So my RB is going to be 98 times 6 the whole over 7. And so my RB from here is going to be 98 times 6 divided by 7. It's going to give me 84 newtons. Because this E is 9.8, the gravitational force there. Multiply this side, then this time this will get 98. Multiply this side and divide by that. So that's our reaction at B. So if we have reaction at B, we can get this frictional force at also B. So our frictional force B is going to be, remember it was a third, sorry, it was a half. It was a half RB. So my FB, it is going to be now a half times RB, which is 84. So my frictional force at B is going to be 42 newtons with ease. So we have that frictional force with ease. Okay. So I have the frictional force at A. I have the reaction at B, I have the frictional force at B. Simple. So now what happens? Now I need to get this and this. So if I have RB, remember from here, my RA, so our RA is equal to a half from here. My RA is going to be equal to a half RB. So meaning that my RA, so it is going to be a half times RB, which is 84. And so my RA is also 42 newtons with ease. If we have now RA, we can get the frictional force at A. So my frictional force at A, remember, it's given by a third RA. So mean that my frictional force at A is going to be a third times 42. And from there, you can see this is going to be, this is going to give us what? 14. Our frictional force at A is going to give us 14 newtons with ease. So I think we have everything. You have the reaction at B, our frictional force at B, you have the reaction at A, you have the frictional force at A. So you have everything. So that's how we handle that basically. See, the ideas we are very, very elegant. So that's it, members. I wish you well.